İnfeksiyöz Laryngotracheitis ve infeksiyöz bronşitis ile ilgili olarak epidemiyoloji ve kontrolü konusunda öğleden önce sunularını izlediğimiz Sayın Zavala ve Bostra'nın prezentasyonlarını ve sunularını izleyeceğiz. Onlara yine sorular soracağız. Sayın Zavala burada mı acaba? Doktor Zavala? Okay. Doktor Zavala, you have the floor, please. Evet. Dr. Zavala, you have 40 minutes and we have 15 minutes discussion. İnfeksiyöz Laryngotracheitis, Patogenezis, Epidemiyoloji ve Kontrolü konusunda Sayın Zavala'nın sunusunu izleyeceğiz. Microphone for you.
Okay, well, good afternoon and thank you again for having me in this meeting. For the next 40 minutes, I will cover a few aspects of infectious laryngotracheitis on epidemiology, pathogenesis, and control. Some of the things that I will mention will be relevant to your situation, and some of them will not, because you only have, for example, 2 types of vaccines approved for use in your country. But I will make comments in reference to all kinds of vaccines that are available in different countries. But what's important is the concepts in general that hopefully will give you a broader perspective. All right, so we worry about infectious laryngotracheitis for many reasons, both in broilers and breeders and also in commercial layers. In broilers, at least in many areas, one of the highest impacts that we see economically is in broilers, because most of the time broilers are not vaccinated when there's no outbreaks, and then when there's suddenly an outbreak, then the losses can be quite substantial in broilers. When it comes to layers and breeders, because most of them are generally vaccinated against infectious laryngotracheitis in most countries, should there ever be a field challenge, the consequences are not as severe, simply because of the fact that they are already vaccinated and because biosecurity, at least in broiler breeders, tends to be quite effective. But most of the losses in terms of broilers will come from mortality, and infectious laryngotracheitis is essentially an upper respiratory disease, and therefore it does not cause increased condemnations at the processing plant. But it can cause increased DOAs, or dead chickens on arrival during transportation, especially in hot weather if they happen to be infected. When it comes to layers and breeders, basically the most important impacts are going to be increased mortality, although it's not going to be very high, and also drops in egg production, simply because infected birds decrease their water consumption, and eventually they decrease their feed consumption and then their egg consumption. Their egg production. Okay, so where do we find infectious laryngotracheitis? We find it just about anywhere in the world, different regions. Some countries have not seen a case of infectious laryngotracheitis for 15 or 20 years, and many other areas have seen infectious laryngotracheitis every single year for the last 15 or 20 years. But the fact of the matter is that infectious laryngotracheitis, or ILT, really has a worldwide distribution, and it can affect broilers, breeders, and commercial layers. Let's look briefly at the pathogenesis of infectious laryngotracheitis. The virus is going to be present in the environment as a result of shedding by infected birds, or as a result of transportation unknowingly by people, vehicles, contaminated equipment, or introduction of birds in multi-age facilities. And once the virus finds susceptible host, which is going to be unprotected chickens, the virus will infect primarily the conjunctival mucosa and the mucosa of the nose. And those are the very first two tissues that are going to be susceptible for virus infection and replication. Thereafter, the virus is going to go to the upper trachea, the larynx, upper trachea, middle trachea, and only on occasion will it infect the deeper tissues of the respiratory tract. And by deeper tissues, I mean the primary bronchi or even the lungs. Yes, on histopathology, we tend to see on occasion evidence of infection through the observation of syncytia and inclusion bodies. But for the most part, again, this is an upper respiratory type of infection. Once the virus has completed its replication cycle, it's going to establish latency or a latent infection, primarily in the deep tissues of the trachea and in the central nervous system, for example, in the trigeminal ganglia or in the brain. And then it's going to remain there for life, like any other herpes virus, waiting for the opportunity to recrudesce the infection and start replicating and shedding again, and representing a risk of infection for other birds in the same flock or other houses in the same farm or even other farms that are at risk of infection. So again, ILT is essentially an upper respiratory disease, and therefore we should not expect to have a significant increase in condemnations in broilers that are infected with this particular virus. As far as clinical signs, most of you are familiar with them. One of the first things that we're going to see is blepharoconjunctivitis with inflammation of the tissues around the eyes, and then increased secretions coming from the nasal orifices and also from the conjunctiva itself. Thereafter, we're going to see obvious respiratory signs and eventually increased mortality until the infection will resolve itself, typically within a matter of 12 days after the first clinical signs of infection. Again, any kind of bird, any kind of chicken is susceptible to infection. Here you have examples in broiler breeder pullets, or in egg layers, or in broiler chickens. As far as the immunopathogenesis, I showed you a quick diagram on the pathogenesis from the moment of infection until the resolution of the infection, which can lead to mortality or a resolution of the case with the survival of the bird, of the infected bird. But for the most part, from the immunological point of view, again, the virus is going to infect primarily the conjunctiva and the nasal cavity. From there, it will go to the upper tissues of the trachea, where it will replicate very actively and cause a lot of damage through cytolytic infection. Then, eventually, it will go to deeper tissues of the trachea and the central nervous system, where it will establish latent infection, and then eventually recrudescence if the flock or the infected bird happens to be immunosuppressed or stressed, or if immunity against herpes virus, in this case, wanes for some reason. Now, while all of this is happening, the bird is going to try to defend itself through an immunological response. And the immunological response is going to be composed of the production of antibodies, although antibody production is not necessarily very effective against infection. It's primarily through T-cell immunity that the bird is going to fight infection. And there's plenty of research that proves that even birds that have been bursectomized and that are unable to produce antibodies are still able to be protected against infectious laryngotracheitis when we do vaccinate them, and even if they don't produce antibodies detectable by ELISA or other methods. So how does immunity work? We really don't know as much as we should when it comes to protection against infectious laryngotracheitis, but the birds produce antibodies that are partially neutralizing for the virus, and that will be primarily IgA. And the bird also is going to mount an innate immune response through, for example, macrophages and dendritic cells, and also fibroblastoid cells that function as antigen-presenting cells. These cells will capture the virus, process it, present it to other components of the immune system, and then the immune system will respond primarily with a T helper 1 type response, which results in cellular type immunity. And in a matter of about 7 days, the bird will completely neutralize the virus, and the virus would no longer be detectable. That's on an individual bird basis. But if we think about a flock, typically from the onset of clinical signs until the resolution of the clinical signs, we usually see a period of about 12 to 14 days. Now, clinical signs. Very typical mouth breathing, swelling of the conjunctiva, swelling of the eyes, increased secretions, foamy secretions around the eyes and the nostrils. And from the practical or production point of view, what we will see in an example like this is mortality goes perfectly okay until the very first indication of increased mortality. Now, before we see the first clinical signs and before we see the first indication of increased mortality, the first thing that an experienced production manager is going to observe is that there's a decrease in water consumption. How do we notice that? We have to have water meters, and we have to record every single day how much water the birds consume. If we see an alteration of that water consumption, something is not right. It could be water pressure, it could be differences in temperature, or it could be infectious disease, and in this case, very classical with infectious laryngotracheitis. Within 24 to 48 hours after the drop in water consumption, you'll see a decrease in feed consumption, depression of the birds, and eventually the manifestation of the first clinical signs and mortality. The mortality pattern in infectious laryngotracheitis in unprotected birds is extremely predictable, because if you had, for example, 50 birds dying one day, the next day you're going to have 100, the next one 200, the next one 400. You have doubling mortality for a period of 5 to 7 days, and then a decrease of mortality that is going to be very sharp, provided there's no complications, and most of the time there is no complications, at least in broiler chickens. Now, in commercial layers and or in broiler breeders, because they tend to be vaccinated flocks as opposed to broilers, you have an erratic or irregular pattern of mortality. You can have ups and downs until eventually you start seeing that there's higher peaks of mortality that sometimes they're not very easily explained, but if you look carefully, you'll start noticing birds with the classical signs, individual birds with classical signs of infectious laryngotracheitis, until mortality really starts peaking, and that's the moment when we should take action. Now, in areas or countries where you only have recombinant vaccines available to you, you really can't do anything therapeutically. In countries where you have either TCO or CEO, chicken embryo origin or tissue culture origin vaccines, you can apply these vaccines on top of the outbreak and you will stop it within a matter of 72 hours. That works very, very well, but you have to have the ability to use those vaccines. Now, let's start looking into what happens in an infected group of birds or a flock of birds. This is obviously based on research, but we've done many experiments looking at different aspects of the infectious laryngotracheitis, and one of the things that is interesting to observe is that this is body or rectal temperatures of birds at the moment of infection, and then you can see how they acquire a feverish state very quickly. That explains why the birds interrupt their water consumption and eventually their feed consumption before they actually start dying with clinical signs of infectious laryngotracheitis. Now, that's very nice to observe this from the scientific point of view and many other aspects, but from the practical point of view, what we need to know to control the disease is that during this incubation period, we don't necessarily see at the beginning of this infection, we don't necessarily see clinical signs of mortality. But the birds are allowing for a very active replication of the virus. They're shedding enormous amounts of viruses. And then if we visit a farm that is exactly at this stage, and then we visit other farms in the same day, we can potentially spread the infection quite easily. In the United States, for example, a typical serviceman visits approximately 24 to 28 different farms in just 1 week. So that gives him or her an opportunity to visit maybe 4 to 6 farms in one single day. If that person visits a farm during this stage and doesn't take the necessary precautions in terms of biosecurity, that can explain very easily how we involuntarily spread infectious laryngotracheitis quite easily. So as far as lesions, you're very familiar with this. On the left-hand side, you have a very severe catarrhal tracheitis, which you can see in cases that are not necessarily very severe, or at the beginning of the outbreak, or at the beginning of infection in an individual bird. Or you can have severely congested tracheas, or frankly, hemorrhagic tracheas that are very classical of the disease, particularly in birds that are completely unprotected and got infected with virulent virus in the field. As opposed to long-lived birds that have been vaccinated, that have at least partial protection, and then you're going to see, or you will tend to see, not exclusively hemorrhagic tracheas or congested tracheas, but you will also see these pseudomembranes that consist of pseudomembranous fibrinoid layer of cellular debris, fibrin, heterophils, macrophages, and red blood cells. Now, when we look at that under the microscope, we identify the pathognomonic lesions that are classical of infectious laryngotracheitis virus infection, and there is nothing really that resembles this, and therefore we can use this as a definitive diagnosis when we identify these syncytia with these Cowdery type A intranuclear inclusion bodies that you can see in these different pictures. Of course, when we inoculate embryos via the chorioallantoic membrane, and then we observe the formation of these plaques, then we can do PCR, or we can do histopathology on those plaques to once again look for these syncytia and intranuclear inclusion bodies. Now, I'm going to go a little bit ahead of myself, but the two methods that we tend to use the most are histopathology, because we can do that within 24 hours, and we also use PCR, or molecular detection methods, which allow us to produce a diagnosis within a matter of just a few hours. This is of particular importance when you have the index case, the very first cases, and you want to identify exactly what the problem is, rule out in Newcastle, rule out influenza, confirm infectious laryngotracheitis, and quarantine the farm, the service person, the company if it's necessary. Do all the things that you have to do from the epidemiology and biosecurity point of view to try and limit the spread of disease. Now, let's talk a little bit more specifically about layers. In layers, again, the first impact is going to be increased mortality, clinical signs, and drops in egg production. There's also, if you want to look at it this way, you also have to incur the cost of vaccination and the cost of the vaccine itself, which in reality are minimal compared to the potential economic problems that you could have if you don't protect your birds. And then from the production point of view, especially in hot weather, hot climates, we can have a potential reduced thermal comfort zone. And I'll explain what I mean by that. Normally, in commercial layers, you obviously have to have a supply of nutrients, and you have specific requirements depending on the production stage, the egg mass, the health of the flock, mortality rate, the quality of the eggshells, a number of different things. But the bird is going to use about 60% of its energy as maintenance. 31% of that energy is going to be used for producing one egg a day on a diet that is sufficiently nutrient for about 100 to 107 grams, more or less. And then 9 to 14% of that energy in the feed is going to be lost as caloric increment. That's the energy that the bird is expending to look for feed, capture the feed, consume the feed, and transit the feed through the intestine without necessarily using it. Now, when the bird gets feverish, when it increases the temperature because of infectious laryngotracheitis, it becomes a lot less tolerant to what we call the comfort zone. The comfort zone, thermal zone, is between 22 and 28 degrees Celsius. Once the bird gets feverish, immediately it will not tolerate any more any other ranges that are outside this zone, and feed consumption will go down, water consumption will go down, and egg production will go down. How long would this last? It can last as long as 14, 21 days, depending on how well protected the flock was before the onset of clinical signs. So what can we do for ILT control? Number one, like for many other diseases, is going to be biosecurity. Number two is vaccination. And number three is proper management of spent fowl and manure, which is really part of biosecurity. One of the biggest offenders in terms of inability to control infectious laryngotracheitis is, what do we do with hens that are at the end of their cycle, and how do we manage them? Where do we send them? How do we transport them? Are they still shedding virus at the moment, yes or no? And that determines how easily or how more difficult it is going to be for us to spread disease to other potential farms. And the other aspect is, what do we do with the manure? You know, many layer houses have manure belts that every day remove the manure from underneath the cages if the birds are in cages. And that manure is going to be composted or heated, dehydrated, sometimes pelletized, etc. But there's a large amount of infectious virus in that manure. So if that manure is removed without any treatment from the contaminated farm, and it's transported to agricultural fields, it can potentially spread virus very easily. And that applies not only to infectious laryngotracheitis, but to other pathogens as well, such as avian influenza virus and Newcastle disease virus. Now let's look at a culture of biosecurity. When it comes to meat-type chickens, I think many of us would agree that the meat-type chicken industry is a little bit ahead in terms of their biosecurity standards. And they also have it a little bit less difficult because they tend to have farms with single ages or with an age spread that is not more than 7 days. If you have a very, very big broiler farm with 500,000 birds, which there are many around the world, you cannot fill a farm with baby chicks in 1 day, a farm of that size. So you have to fill it in a matter of 1 week, for example. But there are many farms in layers that have multiple ages, and that is a recipe for perpetuation of infectious laryngotracheitis, because the farm, as I mentioned this morning, the farm is never empty. So it's not really compatible with disease control. So what we do in any of these areas, whether it's live production or in processing plants or in hatcheries or at the breeder level, is very, very important for disease control. But what I always tell companies that I work with is that not only you should put the pressure on live production, but if you don't have the support from the corporate office, from the owners of the company, or from the managers of the company, it really makes no sense. You're trying to win a battle for which you don't have support. So it's very important that there is a culture of biosecurity and that everybody buys into that culture, from the corporate office all the way to the people that commercialize the chickens. Very important. Same thing with eggs. And you have to identify, every company is different. Broiler companies tend to be a lot more standardized in the way they are structured and the way they operate, but layer companies can be very different. When I started my career, everything was in cages, everything was at a very high density, and the production systems were very similar. Today, we have birds on the floor, birds in aviary systems, birds in rondelle systems, birds in 100% slats or 60% slats, plastic slats, wood slats, you name it. So it's very difficult to provide a universal biosecurity program. Every company has to identify what are the most important risks, and it has to be not only the veterinarian, it has to be the nutritionist, the hatchery manager, anybody that is a manager in different areas for this to be effective. As I mentioned before, how the manure is managed and what is done to it, whether it's composted or not, whether it's heat treated or not, dehydrated, pelletized, bagged, or sold in bulk, is very, very important for what might happen with infectious laryngotracheitis in an ILT infected or affected area. I will not go through all the details, but manure handling is very, very important. Same thing for personnel, vehicles and equipment, live transportation of birds, transportation of litter and spent fowl. And when it comes to vaccination, in your country, you only have recombinant vaccines available to you, but many other countries do have recombinant vaccines, but also chicken embryo origin and tissue culture origin vaccines. And I'll review, if we have enough time, some of the characteristics of these vaccines. So again, I cannot emphasize enough the importance of working with the manure and thinking about the manure as one of the most important risks that you might have for disease control, specifically for infectious laryngotracheitis. This diagram is probably one of the most important messages that I want to leave with you today, and for the following reasons. What this diagram represents is day 0, when a flock is infected, the peak of virus replication and clinical signs, and then when the virus is no longer detectable, either by virus isolation or by molecular detection methods in the birds, not necessarily in the environment or in the manure. But this is very important, and it goes back to the previous concept that I was trying to convey when I was talking about incubation period, the pre-patent period, and when the birds actually start shedding virus. The birds don't start shedding virus the moment you start seeing clinical signs. They start before. And that's something that needs to be emphasized for every person that works in the field. You have to assume every day, every visit to a farm, even if the birds are the healthiest ever, you have to assume that they could be infected with this or with any other disease, and conduct your daily practice in biosecurity that way. So anyways, the birds got infected here. There's active virus replication and shedding, peak of virus replication and shedding, and usually at around 12 to 14 days, we can no longer detect the virus by virus isolation, but we can still detect it by molecular detection methods. And we can actually detect it easily up to 24 days after infection. Now, in our experience, when we work with companies that use chicken embryo origin vaccine, which is essentially the same as if they got infected with a field virus, and we take tracheal swabs and run PCRs on those tracheal swabs at 4 weeks, 5 weeks, 6 weeks, all the way to 7 or 8 weeks, we always find a percentage of birds that are shedding virus. So once the birds are infected, or once they are vaccinated with live attenuated vaccine, you should assume that there will always be a permanent subpopulation of birds that is shedding virus, potentially spreading infection to other farms. Now, areas that are endemic for infectious laryngotracheitis, or where infectious laryngotracheitis can be a real serious problem, are illustrated by that diagram on the right side, on the English version. That is the state of Georgia. Every dot represents a farm. There's close to 5,000 farms in one state that is not really very big. It's the largest broiler producing state, and you can see that in this retrospective study of 540 documented cases, documented by laboratory procedures, the average age of detection is 42 days. That is when the service people, the company people, the company veterinarians, etc., detect clinical signs and bring the birds to the lab, or take samples and bring them to the lab, and the disease is confirmed. So why is this important from the epidemiology and control point of view? Because if my average age of detection is 42 days, and my average age of commercialization of those broilers is 45.5 days, what does that tell you? It tells you that millions of broilers are being sent to the processing plants while they are still actively shedding virus. That is a really bad formula for perpetuating infectious laryngotracheitis in an enzootic area. Now, industry refuses to wait until the birds are not shedding anymore for multiple reasons. The processing plant does not have the equipment to process bigger birds, so you can't wait. And they don't have a market for heavier birds. They're very, very specialized, and the window of body weight and uniformity is so narrow that you cannot wait more than sometimes less than 48 hours. You don't have that flexibility. So that is important for disease control. So let's talk about vaccination. As far as vaccination objectives, you can have many different objectives. Each one of you might have, if I asked you, what is your objective of vaccinating birds? Some of you might tell me, well, I want to prevent mortality. I want to prevent clinical signs. I want to prevent economic losses. Or some of you might say, I want to prevent virus replication and shedding. Or some of you might want the whole package. When it comes to controlling infectious laryngotracheitis, we don't have the ideal vaccine out there in the market. Because ideally, we should be able to prevent disease, prevent outbreaks, prevent clinical signs and mortality, prevent economic losses, and prevent viral shedding. Many of the vaccines that we use are extremely effective. Don't get me wrong, they're very good products. But they all have a little bit of deficiencies that do not allow us to completely control infectious laryngotracheitis. And unfortunately, I would say that a natural human response is that once you have a vaccine, you think that you're protected. My birds are vaccinated, therefore I don't have to emphasize biosecurity. It's both. It's always both. Vaccinating is very important. Biosecurity is very important to help the vaccines, to help your situation. So what available vaccines do we have out there in the market? Different countries, not just Turkey. Well, we have recombinant vaccines based on HVT, or herpes virus of Turkey. There's at least 2 different commercial products. Very soon we'll have several more, where the vector is the herpes virus of Turkey. But we also have recombinant vectored vaccines where the vector is fowlpox virus. Either one of them is they're both very popular in the field, and they both have a place in the field. Very soon, and probably within this year, we will have in the market also recombinant vectored vaccines that protect against the vector, against ILT, and perhaps against Newcastle disease or infectious bursal disease. So you have double inserts for double disease genes plus the vector itself. And then you have the classical tissue culture origin vaccines, which we have in the market since 1963, many years ago, and the chicken embryo origin vaccines, which have been in the market since the 1950s, and that is still what is being used in many, many countries. Very few countries around the world have tried inactivated vaccines. We have tried them both in the field, not in the United States, but in another country, commercial products, and I really, frankly, don't see any benefit, but that's my own personal experience. And part of the reason is that inactivated products, in general, they are very good for triggering a humoral response. They induce the production of antibodies, but in the case of ILT, antibodies are really not necessarily very effective. What you really want is cellular immunity to help you through either a recombinant vaccine or a live attenuated vaccine. So if you look at these products, we won't have time to go into every single detail, but these are some of the things that one has to look at before we choose what kind of product we want to use, especially in those areas that have both recombinant and also live attenuated vaccines. I'm interested in knowing, of course, what vaccine types I have in the market, what is the expected protection, the expected reaction, because that's one of the things that are a major disadvantage of live attenuated vaccines, CEO in particular. What are the application possibilities? I don't want to be handling every individual bird. If I can use mass application methods, for example, recombinant vaccines that can be given in the hatchery, and that can be considered a mass application method. When is the onset of protection? One of the disadvantages of recombinant vaccines is that it might take them 21 to 28 days, depending on the situation, for them to reach their maximum protection level, attainable. It doesn't mean that for the first 3 weeks they don't work. They just keep on increasing their potential, and they reach the peak protection right around 21 to 28 days. And that's something we need to be aware of, especially if we're in an area where we have very early challenge because of high risk of infection. We also are interested in whether they establish latency or not. CO and TCO establish latency. They can recrudesce, and they can backpassage, and they can regain virulence and cause disease problems, the vaccines themselves, which is a great advantage of the recombinant products because they don't do that. And finally, cost. You know, we're in this business of, in reality, we tend to forget that we work in a transformation industry where we take corn and soybeans and oats and we transform them in animal protein, which is essentially eggs and meat from poultry. And in the meantime, we have to work to control disease to make everything happen. That's really our role.
Zavala?
Yes.
5 minutes.
5 minutes. Okay. All right. We have to be careful with some of the pox vectored vaccines. I want to be very careful and not leave you with the impression that there's a problem with these vaccines. There is not. But one of the things that we have observed is that hatcheries that transfer their embryos very early, meaning at 17 days, they can have as little as 0.1, 0.2% of birds where the vaccine reaches the lungs and causes granulomatous pneumonia. But I underline, there is no problem with these vaccines. It's only a very slow percentage, and only if your hatchery transfers your eggs at 17 days of incubation, in which case the embryo will tend to ingest more of the amniotic fluid and causing that little bit of a problem. It really is insignificant from the economic point of view, but it's an interesting thing to observe. So what are the requirements for vaccination success? For live attenuated vaccines, I'm just going to mention that one of the most important aspects for us to make them successful is that we have to have very good coverage. If we don't cover at least 97% of the birds properly, then we will give the virus a chance to backpassage from the vaccinated birds to the not vaccinated birds, gaining virulence and then causing problems in the field. It is not the case with tissue culture, but we don't use tissue culture in broilers. It's not possible to use it by individual vaccination methods, by mass application methods. Another disadvantage is that we can't vaccinate with live attenuated vaccines in close proximity to bronchitis or Newcastle because they will interfere very significantly with each other. We've done plenty of work with that, so I'm going to skip that. And then when it comes to recombinant vaccines, since I'm running out of time, I will mention the most important things. First of all, sometimes industry tends to cut the dose of certain vaccines. They cut the dose for Marek's vaccines, hoping to save some money and still protect against Marek's. With recombinant vaccines, you cannot do that because you really compromise the protection against the insert, LT in this case. Here's an example. These are birds, groups of SPF chickens that were vaccinated with a full dose, half a dose, a quarter dose, or no vaccine. And then they were challenged with a very virulent ILT experimentally. And you can see that as we give them a lower dose, as we fractionate the dose of vaccine, we increase the clinical signs as a result of that. And also the shedding of virus, which is very important. If you really want to control ILT, you have to give a full dose so that you can control shedding of virus. Recombinant vaccines, we have tested them all the way to 74 weeks of age. And in the case of HVT-LT, and we know that POX-LT is a similar case, they can protect layers. And layers, this is an experiment with commercial layers, up to at least for 74 weeks of age. So recombinant vaccines is a mystery. A lot of us ask ourselves, how do they work? Because all we have is an insert. In reality, they work by inducing or stimulating cellular immunity for the most part, not necessarily antibodies. So when you use a recombinant vaccine, a lot of people want to know, well, how am I going to measure whether I did a good job, yes or no? Because I cannot easily detect antibodies against the insert. So in reality, you have to use molecular methods to detect the vaccine that you actually injected in those birds. or you have to use specifically designed ELISA systems that will detect antibodies against the inserts. And as I mentioned that. I will finish with this. In the United States, the broader industry has adopted massively the use of recombinant vaccines, knowing that in the past, CEO vaccines provided better protection. But the problem with CEO vaccines is that when you vaccinate an entire population in a particular company, you give up 2 to 4 points of feed conversion, and you give up half a day of average daily gain. And that is very important economically. So when you use recombinant vaccines, whether they are HVT-LT or POX-LT, you incur the cost of the vaccine, which is usually higher than the live attenuated vaccines, but in the end, you don't have losses from feed conversion losses, 2 to 4 points, which is really a fortune. And in this example, there's one company that produces 1 million birds per week. I'll finish in 30 seconds. Okay. This company produces 1 million birds per week. This is what they spend in vaccine and vaccination. And in reality, comparing to the cost of vaccinating with CEO vaccine, it actually costs them almost $500,000 less to use recombinant vaccine because they don't have the losses from feed conversion points. And with that, I will thank you very much for your attention. Thank you again for the invitation to be in this meeting, and I hope to see you sometime in the future. Thank you.
Thank you very much for your perfect presentation, Dr. Zavala. And şimdi soru bölümüne geçiyoruz. Yaklaşık 10-15 dakika soru sorma imkanımız var. Dr. Zavala, have you had phone?
No.
Bir kulaklık translation için. Evet, önceki oturumda olduğu gibi mikrofon geldikten sonra konuşmaya başlıyoruz. Kendinizi tanıtarak sorunuzu Dr. Zavala'ya sorabilirsiniz.
Yes.
Evet. Buyurun. Sorusu olan. Buyurun İskender Bey. Mikrofonu alalım.
İskender Turan, veteriner hekim. Benim sorum, broilerlerde kesim anında diyelim ki sahada hayvanlarda solunum problemiyle ilgili şüphelerimiz var. Traheyede hiperemi var. Epitel yıkıntılar var. Ama tamamı tedavi edemiyoruz. Kesim anında kan alıp da bu kandan serolojik baktığımız zaman neyi görmemiz gerekir? Titre ne olması gerekir? Ne olması gerekir ki ileriden şüphelenmemiz gerekir? Teşekkürler.
Was I supposed to be hearing a translation?
İskender, daha net olarak sorar mısın?
Broilerlerde sahada yani 45 günlük yaşam süresinde hayvanlarda 3. 4. hafta solunum problemiyle ilgili klinik semptomlar görüyoruz. Otopsi yaptığımız zaman
Now I hear you. Okay.
broilerlerde sahada otopsi yaptığımız zaman hayvanların trahealarında hiperemi yani eksudat ve gözde akıntılar var. Ve bunların kesim anına ilaç verdiğimiz zaman herhangi bir tedavi olmuyor. Bunlar kesim anına geldiği zaman kesimhanede kan aldığımız zaman buna serolojik olarak baktığımız zaman titre ne olması gerekir veya ne görmemiz gerekir? Kendi düşüncesini istiyorum. Teşekkürler.
A lot of times when you collect blood samples to look for antibodies, you don't necessarily see an immediate seroconversion. So there's a chance that the birds could have gotten infected very soon before you send them to the plant, and your blood would give you negative results. It's always better to collect not only serum, but also tracheal swabs for molecular detection. But of course, for that, you can have multiple houses in a farm, and you can be very unlucky and swab exclusively birds that were negative. So it's very important to specifically look for birds that are clinically sick, or even look at your mortality and collect samples from the dead chickens, fresh dead chickens. I don't know if that's really what you were looking for.
Evet, teşekkür ediyoruz. Buyurun.
Sunum için teşekkür ederim. Erhan Bayraktar, SEVA Hayvan Sağlığı. 41. slaytta maternal immünitenin enfeksiyona karşı korumadığı ile ilgili bilgi vermişsiniz. 10. slaytta da şöyle bir bilgi vardı. Broiler sürüleri genelde 48-49 gibi ölümlerin başladığını görüyoruz. Peki bu süre zarfında enfeksiyonun erken şekillenmesini engelleyen faktörler neler olabilir? Teşekkür ederim.
Çeviri olduğunu düşünerek biraz daha yavaş sorarsak, yani konuşurken hızlı değil mi?
No, not necessarily. First of all, maternal antibodies have very little role in protecting the progeny. They only contribute to making very young birds more refractory to early infection. But we almost never see a case of infectious laryngotracheitis before 18 days. Now, as far as how long it takes for them to develop immunity after vaccination, if you vaccinate them with CEO or TCO, it will take them 7 to 10 days to be almost 100% protected, with all the disadvantages that brings. If you use recombinant vaccines at the hatchery, it might take them about 21 to 28 days for them to reach the maximum immunity. Now, what can you do in that period of time while they are building up the immunity? Biosecurity, and then more biosecurity.
Evet, teşekkür ediyoruz. Başka soru? Buyurun. Mikrofonu verelim lütfen.
Veteriner Hekim Aytekin Çoğu. İşletmemiz multi-age, yani farklı yaşlarda hayvanlarımız var. İşletmemize ilete geldi, tespit ettik, teşhis ettik. Ne kadar zaman geçtikten sonra artık işletmemizde ilete yoktur diyebiliriz? Çünkü 3 ay sonra geldiğinde bizim var olan hastalığımız mı tekrar nüksetti, yoksa dışarıdan mı geldi? Bu ayrımı yapmak istiyorum.
Usually you don't get rid of ILT in a layer farm in 3 months. If you have not seen any clinical signs in 3 months and you saw them 3 months ago, most likely you just have a latent infection that has not recrudesced and the virus is not replicating very actively. But perhaps in a more practical situation, you can, if you had ILT in a particular farm, one of the first things that I would ask the farm manager is, how many people do you have per house if it is a multi-age facility? Can you increase the number of people so you can handle each house as an individual epidemiological unit? Because a lot of times what happens is that you might have one person taking care, or 2 people taking care of 2 houses, and move around between houses freely without any necessary biosecurity precautions. So what personnel you have, how many people you have at the farm, is very important to be able to really control ILT in that sense. Now, if you have not seen ILT in 3 months in a farm that already had LT, I would consider the entire farm potentially infected. And if you really want to know exactly which houses are have been infected and are still shedding virus, you do have to run serology and molecular detection methods again to really know what's circulating out there.
Evet. Teşekkür ediyoruz. Başka sorusu olan? Sanıyorum yok. Evet, gördüğümüz gibi iletiği klinik belirti görülmediği zamanda bile iletenin varlığını düşünmemiz gerekiyor. Kesimhane aşamasında bile. O yüzden de laboratuvar muayenelerini sadece serolojik değil, aynı zamanda diğer izolasyon yönünden de değerlendirmemiz gerektiği sonucunu buradan çıkarıyoruz. Sayın Profesör Zavala'ya çok teşekkür ediyoruz. Kendisini yerine alıyoruz. Thank you very much, Profesör Zavala.